everyone. Welcome to your Play Pause It for today. You're actually most likely watching this just on a ViewPeer link if we are still having our K-12 email issues, but nonetheless, I'm so glad you're here with me today. We're going to be covering 4.06 and 4.08 in your OMHS. So go ahead and grab your notes, have that graded assignment open, and let's get going. We're going to be talking about practical graph analysis. So if there's nothing more that math is useful for, it's definitely analyzing graphs. And we're going to try to put mathematical graphs to real world applications. So here's an example. This one is a little bit complicated. There's a variety of graphs going on. 1, 2, 3, 4, 5, 7 different graph lines, but this is representing the market share of products. And you can see along the x-axis, we have the months. And along the y-axis, it says the usage minutes percentage. So this is a video console, it happens to be. It doesn't say specifically which one. So maybe the Nintendo Switch, or the lines are going to tell us exactly which one it is, but it's going to reference video consoles in general. So you can see the darker line is PlayStation 2, and then we have this key here at the bottom. So the thing about graphs, we're not going to analyze this one too much, but I wanted to point out that you want to make sure you understand the units and the increments that the units are going in. So along the y-axis, we have the minutes percentage used. So even though there's not like a percentage sign next to the number, the label on that axis tells us we're talking about cents. And you can see it goes by 5. And then here along the base, along the bottom, we have months. Now, the ones we're going to be looking at are quantitative on both axes, numbers. Quantitative data are numbers. We'll get to some qualitative data, words, when we get to our statistics unit at the end of the year. So let's look at this one. This graph is describing fence installation. So you can see along the x-axis, we have the linear feet of fence, and that goes by 5 feet. And then along the y-axis, we have how much it's going to cost us in dollars. And you can see that it's labeled by 50. So each of these unit or tick marks is going to be 25. They just didn't put them all in. So that's allowed. Our x-axis can go at different increments than the y-axis. So that's going to be super important for you guys to check those different axes and what increments they're using. So the first question here says, what is the slope? So remember, slope is rise over run. The change in y over the change in x. We can just start here and see how far we have to rise to get to another point on the graph. This looks good. So how many units did we rise? So we don't want to say we rose 3 units, right? Because the y-axis does not go by ones, it goes by 25s. So we went up 25, 50, 75. So we rose 75, and then we ran 5 units. We could reduce this, right? Because 5 and 75, they have a common factor. 5 goes into 5 one time. How many times does 5 go into 75? Hopefully you got that. It's 15. So we end up with 15 over 1. 15 over 1 is the slope. So our second question here says, what does it represent? So a lot of times when we have a real world problem like this, we should go ahead and put units to these numbers. So remember the 15, the number on the top, the y value is dollars. So $15 over the x value is feet, 1 foot. So in this scenario, that means you're going to pay $15 per foot. Another way to write that. $15 per foot. So when you get, it's helpful, it's not always necessary, but when you get the slope down with the 1 on the base, it can just be a more valuable number to look at, right? Because the per foot cost is probably pretty helpful. You don't necessarily have to. I mean, we could have said something up here. We could have said $75 per 5 feet. So sometimes it just kind of depends on what the slope will be. If you can get it nice and easy down to 1, but I think that's more helpful to give it a real world sort of meaning or representation. All right, our third question here, what is the y-intercept? So remember, the y-intercept is where it crosses the y-axis, and that's right here at 150. And I know we've talked about making the intercepts coordinate points, so that would be 0, 150, right? But when you're going to talk about what it represents, you're not going to give it as a coordinate point. You're going to give it some meaning. You're going to put some words with it. So what does that y-intercept represent to you? What does it mean when x is 0? That means we have 0 feet of fencing. But look how much it costs. At 0 feet, it costs $150. What do you guys think that could mean? I mean, maybe that's the labor cost, right? You're going to have to pay this company $150 at the start, no matter how much fencing you put in. So it's probably not labor. Maybe it's just an initial, like, to get my business, you have to pay this fee for me to come out to your house, assess your project, and for me to give you a quote. A lot of times companies will do that. But no matter what, up front, before you even decide how much feet of fence you need, you're going to have to pay them $150. So it's sort of that initial cost because feet is 0. All right, our last question says, how much will it cost me to fence in my yard of 18 linear feet? So this is when it can be helpful, right? You're like, okay, I need 18 feet. How much is it going to cost me? So we're going to go along the x-axis to about 18. It's probably about there. And then go up to the graph. It's about right there. Because this is not exact, we're going to say about how much money. We'll go over to the y-axis. Well, that's a nice little spot. About $425. So it's going to be a good estimation tool for you as a consumer if you're looking at having some fence installed. Here's our next example. We're looking at the number of miles traveled along the x-axis, and that's going by tens, and the gallons of gas in your tank along the y-axis, and that's going by ones. So remember, you can have different increments along the different axes. So what is the slope? This one's nice. It already has some labels here for us. We're going to go down 2, and over 1, 2, 3, 4. But don't forget, it's not 4. Look at the units. It's 40. So let's reduce that. That reduces to negative 1 over 20. So what does that mean? And a lot of times, again, to help you get that representation, put some labels on these numbers. Well, what does the 1 represent? That's the gallon of gas. And what does the 20 represent? Miles traveled. Now this line is going down, right? That's what we would expect because the longer you drive anything, whether it's an ATV, a car, an airplane, the longer you use the vehicle, the more gas you're going to use. So it's going to decrease over time. So the slope here represents the number of gallons of gas used per 20 miles traveled. So you're going to lose 1 gallon per 20 miles. Of course, we know in the real world, and some of you who are familiar with cars might be screaming at me right now, is that it's going to depend, right? I mean, is this constant travel? At what speed? Are you, what kind of gas are you using? We are talking about ATV though. Are you stopping and going? So, I mean, there is going to be some variation, but they've given us a model here that we can use to sort of estimate. All right, what is the y-intercept? Here the y-intercept is 4. For what? 4 gallons. So what does that represent? That represents helpful to look at the x value at that time. It's 0, so we've traveled 0 miles. We have not gone anywhere. There's 4 gallons of gas. So that always represents kind of in the last example, the initial amount, the starting amount. So you're starting with 4 gallons of gas in your tank. There's our representation. Lastly, this would be helpful if you're, planning a camping trip and you're going to be taking your ATV with you to ride through the woods. Maybe you're going hunting. My dad uses these hunting all the time. How far will I be able to ride my ATV before running out of gas? You definitely do not want to run out of gas in the middle of the woods somewhere. So how far would I be able to ride my ATV before running out of gas? What do you guys think? A few ways we can do this. We can estimate, right? Graphs are really good and helpful tools in estimation. So we could extend this line. I wish the grid extended, sorry about that, to approximately, if the grid extended, it would be much easier, 80. So we know we're going to run out of gas when this line gets to the x-axis, right? When y equals 0. And that's going to be at about 80 miles. So our gas line will have hit that x-axis, which again represents when y is 0. So you're looking for the x-intercept here when y is 0. And we say y because that is the gallons of gas. And it wants to know when you run out of gas. So when we run out of gas, we will have 0 gallons of gas. So that's why y would equal 0. We could find the equation of this line and plug it in and do it mathematically, and maybe we'll do that in class. But for now, about or an estimation is good. We're using these tools of these lines to make future predictions. All right, let's do this. The whole enchilada. Okay. Tell me about this graph. What could this graph represent in your world? There's a variety of answers. And I'm sure you guys are already thinking of some. I mean, it kind of looks similar to the gas example, right? Because the line is going down from left to right. So we do have a negative slope. So we're losing something over time or over distance. Any ideas? Maybe the amount of time you spend. So this, I don't want to write all over this, but the x-axis could represent the time that you are playing video games. And the y-axis could represent your grade in this class. So maybe the more time you spend playing video games, your grade goes down. Maybe not. This is just an idea. Maybe the more time you spend exercising, right? Maybe your desire for sweets goes down. So anything that sort of has a negative correlation over time, over distance, things like that. So what is the slope? We're going to find the slope the same way. We're going to do rise over run, change in y over change in x. You could even do that slope formula. Remember, y2 minus y1 over x2 minus x1. Here, because we have the graph, let's just find it out. So I know this is a little, I made this one, so sorry, that should be on that coordinate point there. So we're going to go down 1, 2, 3, and over 4. The units on both of these axes are going by 1, so we're good. So we're going to go down 3 over 4. What is the x-intercept? Remember, that's where it crosses the x-axis. So that's right here. And 4, 0. You may also see it written as x equals 4. I know, it's just kind of depending on the question, right? And depending on who wrote the test. Mathematically, this is more accurate, so that's kind of why I pushed that, but you could see it written this way. What is the y-intercept? It is 3, 0. Oops. I rearranged those. 0, 3. Y equals 3. Right? It's where it crosses the y-axis. All right, what's the equation of the line? Remember, we have all those different equations we can pull from. This one's probably the most user-friendly, right? Y equals mx plus b. This is the slope, and this is the y-intercept. I chose this one because we have those two pieces of information. We have the slope and we have the y-intercept. So let's use it and let's just plug it in. Whoa, that's very light. Hold on. Y equals the slope is -3/4 and the y-intercept is 3. There we go. What is the domain? So this is what we finished up in our last class, actually in the playposit that you guys did the last time. So the domain are the x values. So we're going to take a walk along the x-axis from left to right, just like you read a book. And you have to say, where do I hit that graph first? And some of us might say right here. And that's technically correct. But it's not just going to be -3, right? Because this line goes on forever. There's an arrow on the end of it. So that means it goes on forever towards the left and forever towards the right. So when things go on forever and ever, we say it's from -infinity to +infinity. All right, what is the range? So the range are the y values. So again, we're going to pretend like we're maybe not taking a walk or climbing up a mountain from bottom to top. Where does the graph hit me first? And again, this graph is going to the right forever and ever. So eventually we will hit it down here coming up from the bottom. Whoops. So this range is also going to be -infinity to +infinity, all the way up. That just means that no matter what x value you find, you're always going to get a y value out. All right, the last question here, find f of -2. Remember that we read that f of something. Here it's -2. And that's the input, so that's the x value. So what this is really saying is when x is -2, what is y? So we'll go on the coordinate grid at -2 for x, go up to the graph. There it is. It's about, we'll say, what, 4.25? Again, I made this graph, so sorry, it's decimals. But decimals are more real world than whole numbers in some cases. But the idea is you go to the x value, you follow it up to the line, and then find the y value. All right, I want you to try. I want you to pause this video and try to do this on your own, and then come back for the answers. All right, so what did you guys find for the slope? So down here, the time hiked is going by 1 unit, and the distance hiked is going by units of 2. So every 2 miles and every hour along the x-axis. What is the slope? It looks like we have a 1/1 here, right? So 2/1. Remember, because the y-axis goes in increments of 2. So I know this is not a question up here, but what does that mean? And it helps to put labels with it. So it means for every 2 miles, or it's going to take me 1 hour for every 2 miles, approximately. That's the real meaning. The meaning will just sort of jump out at you when you put the labels on it. What is the y-intercept? So that's right here at 4. So y equals 4. And what does that mean? So this is kind of interesting. I never really thought about this. That means that the time is 0. So maybe you're on a trail. No, I don't like this. I don't like this example. Do you guys? I don't think that's nice. But basically what that's saying is no time has passed and the distance traveled has been 4 miles. So, I mean, there's some things we could think about. A lot of times when you park at trail entries, you're not coming in at, you know, mile marker 0. You could be coming in at mile marker 22, mile marker 50. So, I mean, maybe that's the distance hiked on the trail itself. Maybe you just decided to start timing yourself, but you had already gone 4 miles. I mean, these are some stretches. I don't love. You guys see how that's a little that's a little watery there. When we're talking about time hiked and distance hiked, you would expect that if your time is 0, you haven't hiked any time at all or any distance at all. This word hiked is what I don't love. But I do think you can see this in the real world because I live near the W&OD Trail. I don't know if you guys are familiar with that trail, Washington and Old Dominion Trail in Northern Virginia. And there's like so many different places you can park to enter onto the trail. And we're always wondering what mile marker are we at? So we could change this label sort of to the mile marker. Maybe we started at mile marker 4 at 0 time. What is the equation of the line? So we have everything we need, right, to just plug it in. Y equals the slope is 2 over 1, and the y-intercept is 4. There we go. You could definitely write this without the 1. Remember, there's always a 1 implied there under every number. It's up to you. Either one of these would be correct. What is the domain? So the domain are x values. So this graph is only showing the first quadrant. So that's the values that we're going to look at. Here it starts at 4. There's no arrow. And there's no hole. You know, some graphs we've seen have a hole and then a line. There's no hole. It's a solid line, so that means 4 is included. So we're going to start at 4 with a bracket because it's included. And then we're going to go on forever towards the right. So it goes on forever to infinity. Remember, we always have a parentheses on infinity because it's never allowed to actually equal infinity. Because infinity is not a unique number, so we would never equal it. What is the range? What are the y values? So the graph starts again. Oops, did you guys see that? My mistake. Here, the domain are the x values. So we start at x equals 0. I hope you caught that. I did very quickly. What is the range? The range are the y values. So here we start at 4 and go to infinity. So domain is x, range is y. And our last one here, find f of 4. F of 4. Remember that's the input. It is inside those parentheses, so that's the x. So when x is 4, we go up to the graph. Whoops. And we go over to the y-axis and get, 12. So f of 4 equals 12. Remember, this is x, and this whole thing is y. Awesome job, you guys. I will see you next class. Just a quick reminder that if you are still working on or need help with that 4.04 extended assignment, just make sure that you've watched the Play, Pause It, View Peer link from November 12th from last week because I go over the first question in that video. So just make sure that you've watched that. And of course, if you still need help after that, just reach out to me. I'm going to be grading these because these are teacher graded, so I get to look at every single one. I'm so excited to see your work. I'm going to be grading these over our teacher work days on, what date is that? I'll show you. Our teacher work days are on the 23rd and the 24th of November. So the 23rd and the 24th are the teacher work days, and then the 25th through 27th is your fall break. Exciting! So yeah, I will be grading these 4.04 assignments these days. All right, you guys, I'll see you in class. Thanks for watching, everybody. Bye.